Assalamualaikum and a very good day. Today we are going to have a look on the chapter factors of polynomials. To me, in this chapter there will be 5 main parts. The first part is polynomials. What is polynomials? Second part is dividing polynomials, which means that we want to learn how to do long division. The third part is the remainder theorem. The fourth part is factor theorem. And the last one is to solve cubic equations. Let us start with what is polynomials. By definition, a polynomial in the variable of x involves sum of terms where each term is in the form of ax to the power of n, where a is a constant and n is a non-negative integer. For example, if we have 3x cubed plus 2x squared plus x minus 4. This is an example of polynomials. If you look at the power of x, we have x to the power of 3, x to the power of 2, and x to the power of 1, where the power of x needs to be a non-negative integer. The value of n needs to be a non-negative integer. 3 needs to be a non-negative integer. 2 and 1 needs to be a non-negative integer. What does it mean by integer? Integer is not decimal, non-fraction. Or I can say that integer is nombor bulat. So for an expression to be a polynomial, the power of x needs to be a non-negative integer. If you have a negative integer, then it is not a polynomial. Let's have a look at example of polynomials. Look at the first example. We have 8x cubed minus x squared plus 3x plus 4. The value of n for each term from the first example is positive. It's non-negative. So it is a polynomial. Look at the second example. We have 5x to the power of 4 minus 1 over 12x plus 1. So again, the value of n here is a positive integer. Although we have coefficient of x to be in a fraction, it doesn't really matter. On the third example, we have 7x to the power of 3 minus 6x squared plus 0.1x minus 107.8. Again, the value of n is a positive integer. Although we have 0.1 coefficient of x in a decimal form, it doesn't really matter. Still, we'll consider the third example as a polynomial as long as the power of x, which is the value of n, is a non-negative integer. Now let's have a look at the example of non-polynomials. If you look at the first example, we have x squared minus 2x to the power of 1 over 2 plus 6. This is a non-polynomial because the power of x is in fraction. Again, by definition, n cannot be a fraction. It has to be a non-negative integer. So the first example is not a polynomial. If you look at the second example, we have x squared plus 1 over x minus negative 2. And if I rewrite this expression, it becomes x squared plus with x to the power of negative 1 minus 2. Here we have the power of x equals to negative 1. So this is an example, another example of non-polynomial because n is a negative integer. And again, from definition, n cannot be a negative integer. The third example is also an example of non-polynomials because we have sin x. If we have sin x or cos x or tan x, then the expression is not a polynomial. Now let's have a look at the degree of polynomials. If you want to know the degree of polynomials, we always refer to the highest power of x. For example, we have examples of polynomials here. The first example, x squared plus 2x minus 1. Since the highest degree of x is 2, so the degree of the polynomials is 2. For the second example, the highest power of x is 1, so the degree of polynomial is 1. For the third example, if you notice, the highest degree for the power of x, the highest power of x is 33 instead of 22. So the degree of the third polynomials is 33. We have done our first part of the chapter, which is getting to know what is polynomial, so we can cancel out the first main part. Now we are going to have a look at dividing polynomials. Technique to use when we divide polynomials is known as the long division. For example, we divide 2x to the power of 4 plus x squared minus 3x cubed plus 1 by x minus 2, then express in terms of dividend equals to quotient times divisor plus with remainder. Before we start with the long division process, the first thing we will need to rearrange the polynomial from terms with the highest power to the lowest power. So from highest to lowest power. In this case, we are given this expression, polynomials. We rearrange that from highest power to the lowest power. So we rewrite 2x to the power of 4, settle with that, minus 3x to the power of 3, settle with that, plus with x squared, settle with that, plus with 0x. Although we don't have any term with just x to the power of 1 here from the original polynomial, we need to add where we need to add the term by adding 0x before we do long division, and the last one is plus 1. So divide that with the divisor x minus 2. The divisor has been arranged from the highest power to the lowest power, so there's no problem there. Okay, let's have a look at the first step. What do we need to do? First step, what times with x should get 2x to the power of 4. So what times with x should get 2x to the power of 4. Basically, that what is just equals to 2x to the power of 4 divided by x, which is just equals to 2x to the power of 3. So here we have 2x to the power of 3. Second step, let 2x to the power of 3 times with x, we will get 2x to the power of 4. And 2x to the power of 3 times with negative 2x, we will get negative 4x to the power of 3. Underline that. Top minus with bottom. Okay, so top minus bottom. Top minus bottom, we will get 2x to the power of 4 minus with 2x to the power of 4, we will get a 0. But we don't write 0. Just leave the answer like that without writing 0. Next one will be top minus bottom, negative 3x to the power of 3 minus with minus 4x to the power of 3. So top minus bottom. Okay. So again, we will get negative 3x to the power of 3. Negative times with negative, we'll get positive plus 4x to the power of 3. So 4x to the power of 3 minus 3x to the power of 3, you should get x to the power of 3. So we write here x to the power of 3. And bring down plus x squared. Okay. So we've done with the first part of the long division. Now, the same process goes. What times with x should get x to the power of 3? What times with x should get x to the power of 3? So that what is just equals to x to the power of 3 divided by x, which is just equals to x squared, positive x squared. So you write plus x squared here. Okay. The next step will be x squared times with x. You should get x cubed. X squared times with negative 2, you should get minus 2x squared. Again, top minus bottom. So line that. X cubed minus with x cubed, you should get 0, but we don't write 0. Leave it like that. X squared here, x squared minus with negative 2x squared. So plus x squared minus with negative 2x squared. It's just equals to x squared. Minus minus, we should get plus 2x squared. So becomes 3x squared. So here 3x squared. Now bring down the next term. Plus with 0x. Again, the same process will be done. Okay. Okay, what times with x should get 3x squared? Okay, what times with x should get 3x squared? So that what is just equals to 3x squared divided by x. So 3x. So here you write down plus 3x. Okay, plus 3x. Next, 3x times with x, you should get 3x squared. 3x times with negative 2x, we get minus 6x. Okay. Next will be top minus bottom. Okay. Top minus bottom. So you line that up. Top minus bottom. So 3x squared minus 3x squared, we get 0, but we don't write 0. 0x minus with minus 6x is equals to 0 plus with 6x. So it's just equals to 6x. Then bring the last part down. Plus 1. Again, the same process goes. What times with x should get 6x? Okay. What times with x should get 6x? So that what is equals to 6x divided by x, which is just equals to 6. So we write down plus 6. So plus 6 times with x, we should get 6x plus 6 times with negative 2, negative 12. Again, top minus bottom. Top minus bottom. Here, top minus bottom. So 6x minus 6x, you'll get 0. But we don't write 0. 1 minus with minus 12 is just equals to 1 plus with 12, which is just equals to 13. So the remainder ataupun baki is just equals to 13. So that's the end of our long division. Let me resize this. Okay. Okay. Right. From our long division, the original polynomials is known as the dividend. Okay. This is known as this dividend. In a symbol, sometimes they write it as f of x. Okay. And here is divisor. So, or x minus a. And top here is the quotient, which is just qx. And down here is the remainder, or r. If you want to write in terms of dividend equals to quotient times divisor plus remainder, so we just write down the equation, the polynomials directly. So our dividend is just equals to 2x to the power of 4 plus with, you can just take the original equation, doesn't really matter. Sorry. Okay. Minus with 3x cubed plus with x squared. You don't have to write 0x. Plus with 1 just equals to, that is the dividend. Quotient is equals to 2x to the power of 3 plus x squared plus 3x plus with 6. That is our quotient, and don't forget to put it in a bracket, times with our divisor, which is just x minus 2 plus with our remainder, which is just 13. So f of x equals to qx times with x minus a plus with our remainder. Right. So this is our final answer. Now let's have a look at another example. Divide 3x to the power 4 minus x squared plus 8x minus 4 by with x plus 1. Again, the first thing we need to rearrange from the highest power to the lowest power for both the polynomials and also the divisor, dividend and divisor. So we write down here 3x to the power of 4. Done. Is there any terms with x to the power of 3? No terms with x to the power of 3, so we just write plus 0x to the power of 3. Done. Minus with x squared. Done. Plus with 8x, done here, minus with 4. Okay, so we line that up. We will divide this polynomial with our divisor, which is x plus 1. Again, the first step. What times with x should get 3x to the power of 4? So what times with x should get 3x to the power of 4, that what is just equals to 3x to the power of 4 divided by x. You should get 3x to the power of 3. So write down here 3x to the power of 3. Next step would be 3x to the power of 3 times with x. You should get 3x to the power of 4. 3x to the power of 3 times with plus 1. You should get plus 3x to the power of 3. Line that up. Next step will be top minus with bottom. Top minus bottom, we can easily see that 3x to the power of 4 minus with 3x to the power of 4, you should get 0, but we do not write the 0. 0x to the power of 3 minus with plus 3x to the power of 3, which is just equals to 0x to the power of 3 minus with 3x to the power of 3. So this we will get 0. Final answer is negative 3x to the power of 3. So the remainder, the balance here, we will get negative 3x to the power of 3. And then we will move the next term down here. So it becomes minus x squared. Okay, done with the first part. Now, again, the same process. What times with x should get negative 3x to the power of 3? What times with x should get negative 3x to the power of 3? That what is just equals to negative 3x to the power of 3 divided by x. So we will get negative 3x squared. So here, you write negative 3x squared. Next step will be negative 3x squared times with x, we will get negative 3x cubed. Negative 3x squared times with plus 1, we will get minus 3x squared. Again, top minus bottom. So line that up. So we can easily see that the first part, negative 3x cubed minus with minus 3x cubed becomes negative 3x cubed plus with 3x cubed will become 0. So here becomes 0, but we do not write that down. Just leave an empty space there. Next will be negative x squared minus with minus 3x squared. So which is just equal to negative x squared plus with 3x squared. So easily see that becomes 2x squared. So here becomes plus 2x squared. And we bring down the next term, plus 8x. Again, we will do the same process. Okay. What times with x should get 2x squared? What times with x should get 2x squared? So that what is equals to 2x squared divided by x, so equals to 2x. So we write down here plus 2x. Plus 2x times with x should get 2x squared. Plus 2x multiply with plus 1, you should get plus 2x. And again, top minus bottom. So top minus bottom. Line that up. Top minus bottom, easily see that 2x squared minus 2x squared, we will get 0. 8x minus with 2x, we will get 6x. Bring down the next term, which is negative 4. Again, the same process. What times with x should get 6x? Okay, what times with x should get 6x? So that what will be 6x divided by x, 6. So we just write down plus 6. Next step will be plus 6 times with x, we will get 6x, plus 6 times with plus 1, we will get plus 6. Top minus with bottom. So 6x minus 6x, we will get 0. Negative 4 minus with plus 6 equals to negative 4 minus 6 equals to negative 10. So the remainder is equals to negative 10. So we've completed our long division. Now the question wants us to express in terms of dividend equals to quotient times with divisor plus remainder. So we just rewrite the whole equation into the form that they want. It will becomes our dividend 3x to the power of 4 minus with x squared. 0x you don't have to write that one. Okay, will just equals to 0. So just write 3x to the power 4 minus with x squared plus 8x minus 4 is just equals to, that is our dividend. Or sometimes they write it in terms of f of x. Okay, equals to our quotient qx just equals to 3x to the power of 3 minus 3x squared plus 2x plus 6, and remember to write our quotient in a bracket times with our divisor, our divisor is x plus 1, so this is our divisor, x minus a, and then plus with our remainder, which is negative 10. So that is our final answer. Now let's have a look at one more example involving the divisor with 3 terms. The same process will be used, so let's have a look on what we should need to do. Again, the first thing before we do the long division, we need to rearrange from the highest power to the lowest power, the terms with the highest power to the lowest power. In this case, we have 9x to the power of 5, done with that, plus with any terms with x to the power of 4, no, so you just write 0x to the power of 4 plus with any terms with x to the power of 3, yes, one term, so minus with 10x to the power of 3 plus with 12x squared, and then plus with 4x minus with 2, and we line that up. Sorry, taking some time to do that. Okay, and this polynomial will be divided by another polynomial, which is 3x squared plus 2x minus 1. So for the divisor, you still need to make sure that the arrangement of the terms would be from the highest degree to the lowest degree, from the x with the highest power to the x with the lowest power. Again, the same process. What times with 3x squared should get 9x to the power of 5? So what times with 3x squared should get 9x to the power of 5? So that what is just equals to 9x to the power of 5 divided by 3x to the power of 2. So we get 3 squared, so balance. So we get 3x to the power of 3. So write down there 3x to the power of 3. And then we multiply 3x to the power of 3 times with 3x to the power of 2, we will get 9x to the power of 5. 3x to the power of 3 times with plus 2x, we will get plus 6x to the power of 4. 3x to the power of 3 times with minus 1, we will get minus 3x to the power of 3. Next step, top minus bottom. So line that up. Obviously, the first term 9x to the power of 5 minus with 9x to the power of 5, we will get 0, but we don't write 0. 0x to the power of 4 minus with 6x to the power of 4, we will get minus 6x to the power of 4 minus 10x to the power of 3 minus with minus 3x to the power of 3 is equals to minus 10x to the power of 3 plus with 3x to the power of 3, we will get negative minus 7x to the power of 3. So here becomes minus 7x to the power of 3. Bring down the next term, plus 12x squared. Okay. And the same process goes. What times with 3x squared should get negative 6x to the power of 4? What times with 3x squared should get negative 6x to the power of 4? So that what is just equals to negative 6x to the power of 4 divided by 3x squared. Negative, positive, negative 6 divided by 3, 2. And the x will be x squared. So it becomes negative x squared. So our what is negative 2x squared. Next will be negative 2x squared multiplied with 3x squared becomes negative 6x to the power of 4. Negative 2x squared times with plus 2x becomes negative 4x cubed. Negative 2x multiplied with negative 1 becomes positive 2x squared. Line that up. Again, top minus with bottom. Top minus bottom. Negative x to the power of 4 minus with negative 6x to the power of 4. Equals to negative 6x to the power of 4 plus with 6x to the power of 4, we'll get 0. It's obvious that the first term will always get 0, so you don't have to write down 0. Next one would be negative 7x cubed minus with minus 4x cubed equals to negative 7x cubed plus with 4x cubed, we will get negative 3x cubed. So just write down the negative 3x cubed. 12x squared minus with 2x squared, we will get 10x squared. Next term, we will bring down the next term, which is just 4x plus 4x. And again, the same process. What times with 3x squared you should get negative 3x cubed? So what times with 3x squared should get negative 3x cubed? So So that what is just equals to negative 3x cubed divided by 3x squared. So becomes negative x. So just write down negative x here. Next step will be negative x multiplied with 3x squared. We will get negative 3x cubed. Negative x multiplied with plus 2x, we get negative 2x squared. Negative x multiplied with negative 1, we get positive x. Again, top minus bottom. Line that up. The first term will always equals to 0. Second term, 10x squared minus with minus 2x squared, which equals to 10x squared plus with 2x squared, which is equals to 12x squared. 4x minus x, easily see that it will equals to plus 3x. Now we bring down the last term, which is minus 2. And again, repeat the same process. What times with 3x squared should get 12x squared? Should be plus 4. Right, we will get plus 4. Next step will be plus 4 times with 3x squared. We will get 12x squared. Plus 4 times with plus 2x. We will get plus 8x plus 4 times with minus 1 will be minus 4. Top minus bottom, as usual. Top minus bottom. 0 for the first term. For the second term, 3x minus 8x, we will get negative 5x. The third one, negative 2 minus with minus 4, which just equals to negative 2 plus with 4, which is just equals to 2, so plus 2. And yeah, that's the end of our long division. Let me see. Okay. Now we can rewrite the long division in terms of dividend equals to quotient times divisor plus remainder. So our dividend f of x is just equals to this one. That is f of x. Our quotient qx equals to this one. Our divisor x minus a, in this case it's not x minus a, it's a more complex set than that, and but we know that this is our divisor, and our remainder r is just negative 5x plus 2. So we just rewrite in terms of, we express in terms of what the question wants. So just write down 9x to the power of 5. This is plus, okay, plus with 0x, you don't have to write, minus with 10x to the power of 3, plus with 12x squared, plus with 4x minus 2, just equals to, that is our dividend, so it's equals to our quotient, 3x to the power of 3 minus 2x squared minus x plus 4 times with our divisor, 3x squared plus 2x minus 1 plus with our remainder. Our remainder is negative 5x plus 2. That should be your final answer. But if you want to simplify this by opening up the bracket, the answer will also be accepted. But I think if we leave our answer in this form, that should be enough. We have done the first two parts of this chapter. Now we are going to have a look at the third part, which is the remainder theorem. So what is the remainder theorem? The remainder theorem states that if a polynomial f of x is divided by a linear divisor, x minus a, then the remainder is fa. Or we can also say that if a polynomial fx is divided by a linear divisor, ax minus b, then the remainder is f b over a. Okay. What does it mean by linear divisor? So the divisor here is linear, obviously, because x is to the power of 1. And here we also have a linear divisor because x is to the power of 1. And we know that in general, linear equation is just y equals to mx plus c, where x is to the power of 1. If we have quadratic equation, then we have x squared. Cubic equation, we have x to the power of 3. So linear divisor means that x is to the power of 1. Alright, let us have a look at how to apply the remainder theorem. Again, remainder is just baki. Kalau dalam bahasa Melayu tu baki lah. Okay. So we have remainder theorem. Example, find the remainder when 4x to the power of 3 minus 5x plus 1 is divided by x minus 2. According to the remainder theorem, if a polynomial is divided by the linear divisor, then we can have the remainder equals to fa. Okay, let me put in this way. Okay, first you let the divisor x minus 2 equals to 0. Always let the divisor equals to 0. And we have x equals to 2. Okay. So, by remainder theorem, the remainder r is just equals to f2, which is just equals to 4 2 to the power of 3 minus 5 times 2 plus 1. Just insert x equals to 2 into this particular expression. So the final answer should be, let me see. I need a calculator. So this is just 4 times with 8 minus with 10 plus 1. So the final answer is 23. The remainder, when 4x to the power of 3 minus 5x plus 1 is divided by x minus 2, is 23. Okay, let's have a look at another example. Find the remainder when 4x to the power of 3 minus 5x plus 1 is divided by x plus 3. Again, the technique. First, let the divisor x plus 3 equals to 0. Hence, we have x is equals to minus 3. By remainder theorem, r is just equals to f negative 3. So, which is just equals to 4 times negative 3 to the power of 3 minus 5 times with negative 3. Okay, again. 4 times with negative 3 to the power of 3 minus 5 times negative 3 plus with 1. The answer should be negative 92. Okay, one more example. Find the remainder when the same polynomial is divided by 2x minus 1. So the divisor, let divisor 2x minus 1 equals to 0, which means that x is just equals to 1 over 2 by remainder theorem. R is just equals to f 1 over 2, which is just equals to 4 times with 1 over 2 cube minus 5 times with 1 over 2 plus 1. Final answer should be negative 1. So the remainder is negative 1. When we divide 4x to the power of 3 negative minus 5x plus 1 with 2x minus 1, we will get the remainder negative 1. Now let's move on to a slightly more complicated example. Expression 4x squared minus px plus 7 leaves a remainder negative 2 when divided by x minus 3. Find the value of p. It's quite easy. First, this is our divisor. So let divisor x minus 3 equals to 0. Therefore, we have x equals to 3 by remainder theorem. When this function 4x squared minus px plus 7 is divided by the linear divisor x minus 3, the remainder is negative 2. So by remainder theorem, we have r equals to f3. The remainder from the equation is given negative 2 equals to 4, 3. So we just insert the value of x equals to 3 into the equation of f. So we have 4 times 3 squared minus p times 3 plus 7. So rearrange that. We will get negative 4 times with 9 minus 3p plus 7 equals to negative 2. Negative 2 equals to 4 times 9 is 36 minus 3p plus 7. 3p is equals to 36 plus 7 plus 2. So 3p is equals to 45. P equals to 45 divided by 3. P is equals to 15. Okay. So the remainder theorem is quite easy. So let's have a look at another example. Given that 2x to the power of 3 plus ax squared plus bx plus c leaves the same remainder when divided by x minus 2 or x plus 1. Prove that a plus b is equals to negative 6. Okay. According to the remainder theorem. We have our divisor x minus 2 or x plus 1. So let divisor x minus 2 equals to 0, so that x is equals to 2. Hence, we will have remainder equals to f2. And for the second divisor, the same process. Let x plus 1 equals to 0. Therefore, x equals to negative 1. Hence, remainder is equals to f negative 1. From the equation, it is stated that when this polynomial divided by x minus 2 or x plus 1, we will get the same remainder. Technically, both of these will be the same. We will get the same value. Hence, we can say that f2 is just equals to f negative 1. So what you do, you just insert the value there. So we have 2 to the power of 2 to the power of 3 plus a 2 squared, sorry, to this equation, plus with b times 2 plus with c is equals to 2 times negative 1 to the power of 3 plus with a times with negative 1 to the power of 2 plus with b times negative 1 plus with c. And we have, we can see that we can cancel out c and c, because once c is, once we bring plus c to the left hand side from the right hand side, we will get c minus c. So we technically we will cancel c on both sides, and then we will have here 16 plus 4a plus 2b on the left hand side will equals to negative 2 plus a minus b. Next step would be we will gather all the a's and b's on the one side and the one without a and b on the right hand side. So I'll bring both of these here and that one there. So we will have 4a minus a plus 2b plus b equals to negative 2 minus 16. 4a plus a will be 3a plus 3b equals to negative 18. Okay, let me shrink this a bit. Okay, and then we can factorize 3. A plus b equals to negative 18. So a plus b equals to negative 18 divided by 3. Hence, a plus b is just equals to negative 6. It's proven. Let's get back to our remainder theorem again. If a polynomial fx is divided by a linear divisor, then the remainder is just fa. It's more to like you do more exercises and you will understand the how we want to use the remainder theorem. We have looked at the three main parts of this chapter. Now we are going to continue with the fourth part, which is the factor theorem. The factor theorem states that if x minus a, which is a linear divisor, is a factor of fx, then fa is equals to 0. Or if we put it in this way, if ax minus b is a factor of fx, then fb over a is equals to 0. Take notice that these both are linear divisor. obviously, if you have something, say something 4, and you divide that thing with its factor, which in this case, for example, 2, then the remainder will be 0. So what's the factor theorem trying to say is that if we have a linear divisor which is a factor of a certain polynomials, then the remainder should be 0. That is what the factor theorem trying to say. Okay. Again, if we have a certain divisor which is a linear divisor which is a factor of a certain polynomials, then the remainder will equals to 0. Let's have a look. Show that x to the power of 4 minus 3x squared plus 2x plus 4 is divisible by x plus 1, which means that we need to show that x to the power of 4 minus 3x squared plus 2x plus 4, when we divide this equation with x plus 1, when we do the long division, the remainder will be 0. But this will take sometimes to do it. You can do it in this way, the long division, but there's a simpler method which is by doing the factor theorem. Okay, factor theorem states that if by factor theorem, let me do it this way, using different color. That divisor x plus 1 equals to 0, therefore we have x equals to negative 1 by factor theorem. If x plus 1 is a factor of f of x, then f negative 1 should equals to 0. So we check the value of f of negative 1. So f negative 1 is just equals to negative 1 to the power of 4 minus with 3 times negative 1 to the power of 2 plus with 2 times negative 1 plus with 4. So obviously the first part we get 1, second part we will get 3, third part we will get minus 2, fourth part we will get 4. So when we add everything, you should get 0. Yes, we can confirm that x plus 1 is factor. We can say that x to the power of 4 minus 3x squared plus 2x plus 4 is divisible by x plus 1. What does it mean by divisible? It means that we can divide this polynomial with this polynomial without any remainder. And by factor theorem, we can see that the remainder is just equals to 0. Okay, let's look at example from your topical past year. Page 21, example 3, October, November 2014, paper 2-1, question 12. It's on page 21, your topical past year. Okay, the first question, show that x minus 2 is a factor of 3x cubed minus 14x squared plus 32. So if x minus 2 is a factor, Means that if we divide this polynomial with x minus 2, the remainder should be 0. Okay, let divisor x minus 2 equals to 0, then x equals to 2. Then we check for the remainder. R equals to f2, which is just equals to 3 times 2 to the power of 3 minus 14 times 2 squared plus 32. Use your calculator. Okay, minus 14 times 4. So the answer is 0. So the remainder is equals to 0. Hence, by factor theorem, we can say that x minus 2 is a factor of 3x cubed minus 14x squared plus 32, since remainder is equals to 0. Okay, and in exam you don't have to write this. You don't have to write this. Showing this part here is enough for you to get full mark for this particular example. Okay, next one. Hence, factorize 3x to the power of 3 minus 14x squared plus 32 completely. So what you need to do here, you need to do long division. Okay. So we just do the long division. We have 3x to the power of 3 minus 14x squared plus 32 divided by x minus 2. Again, what times with x? We get 3x cubed. So we need 3x squared times with x, we get 3x cubed. And then 3x squared times with negative 2, you should get negative 6x squared. Top divided by bottom, not top divided by bottom, top minus bottom. So we get negative 8x squared plus with 32. Okay, and then what time with negative 8 and what times with x we get negative 8 squared? I will need negative 8x. So negative 8x times with x, we will get negative 8x squared. Negative 8x times with negative 2, we get positive. Oh, I'm sorry, I forgot that we need to do plus 0x. Let's do it again. Let's do one example from Topical Past Year, page 21. Example 3, October, November 2014, paper 2-1, question 12. Show that x minus 2 is a factor of 3x cubed minus 14x squared plus 32. First step, let x divisor x minus 2 equals to 0. So we have x equals to 2. And if this is the factor of this polynomial here, then we should have remainder equals to 0. So from the factor theorem or remainder theorem, so we just find the remainder. R is just equals to f2. So we insert the value of 3 times 2 to the power of 3 minus 14 times 2 squared plus 32. And press your calculator, you will get 0. since the remainder is equals to 0, then we can say that by factor theorem, x minus 2 is a factor of 3x cubed minus 14x squared plus 32. Okay, so in the exam you just need to show this. Since the remainder is 0, then x minus 2 is a factor. Okay, next one. Hence, factorize 3x cubed minus 14x squared plus 32 completely. So means that since this is 3x cubed minus 14x squared plus 32, I would expect that we will have something like this. If it's x squared, then we have, if we factorize, we will have two brackets. Since this is x to the power of 3, hence if we factorize, we should have 3 brackets. Okay, so the first idea is we need to do long division. And so we need to divide 3x to the power of 3. Again, long division, you have to rearrange the formula from terms with the highest power, highest degree to the lowest degree. Okay, so we have 3x cubed minus 14x squared plus with no x, but you need to add x, 0x plus with 32. Okay, and we divide this with its factor, of course. In this case, it's x minus 2. And do the long division like usual. Let me resize that so that we will have more space to do the workings. Okay. Right, again, the process of long division. What times with x, we will get 3x cubed. So we should times x with 3x squared. 3x squared times with x, we will get 3x cubed. 3x squared times with negative 2, we will get negative 6x squared. And top minus bottom, 3x cubed will be cancelled. Negative 14 minus with minus 6. So you should get negative 8x squared, and bring down the next term plus 0x. Again, what times with x should get negative 8x squared? We should multiply with negative 8x. So negative, positive, negative, 8 times 1, 8, x times x, x squared. Then multiply negative x with negative 2, negative times negative, positive, 16x. Top minus bottom. The first term always cancel out each other, so 0x minus 16x, we should get negative 16x. Then bring down the next term, which is plus 32. What times with x should get negative 16x? Should times with negative 16. Negative 16x times with x, we should get negative 16x. Negative 16x times with negative 2, we should get plus 32. Top minus bottom, the remainder will be 0. Now we write in terms of dividend equals to quotient times with divisor plus with remainder. Our dividend is 3x to the power of 3 minus 14x squared plus 32 equals to, our quotient is 3x squared minus 8x minus 16 times with our dividend, which is just x minus 2, plus with our remainder, which is just 0. So you don't have to write the remainder, it's just equals to 0. Again, let me resize this so that we will have more space to deal with the next part. Okay, here. Notice that we can actually factorize a quadratic function. So if you factorize that, it will become 3x and x. So let me see if I have 4 and 4. Maybe you can do that. Okay. Okay. So when I factorize 3x squared minus 8x minus 16, I will get this. Okay. And then obviously we need to multiply with that one, which is just x minus 2. So we've done factorizing this question. So the answer is 3x to the power of 4 and 3x plus 4 times with x minus 4 times with x minus 2. So we have done factorized completely. Let us do one more example. Given that fx equals to 3x plus 3 to the power of 4 minus k plus x squared minus 12 has a factor of x plus 1. Factor of x plus 1, which means that the remainder when x equals to negative 1 should equals to 0. Find all the possible values of k. Okay, by the factor theorem, okay, if we let the divisor, if x plus 1 is a factor, then let divisor x plus 1 equals to 0, hence we have x equals to negative 1. If x plus 1 is a factor, this is by factor theorem, then we should have f negative 1 equals to 0. So this is our f, which means that 3 times with negative 1 plus 3 to the power of 4 minus with k plus with negative 1 squared minus with 12 should equals to 0. So press your calculator, you should get the first part is 3 times minus 1. It's 48 minus with k minus 1 squared minus 12 equals to 0. I'll bring this to the right hand side, so I should get k minus 1 squared is equals to 36. So k minus 1 equals to square root of 36 plus minus. So we have k minus 1 equals to 6, or k minus 1 equals to negative 6. Hence k is equals to 6 plus 1, which is equals to 7, or k is equals to negative 6 plus 1, which is equals to negative 5. We have two values of k. Okay. Now let's have a look on question which involve both the remainder and the factor theorem. You can see in this in your topical pass here, page 22, example 4. Okay, the expression 2x to the power of 3 plus ax squared plus bx minus 30 is divisible by x plus 2, which means that x plus 2 is a factor of that polynomial, and leaves a remainder of negative 35 when divided by 2x minus 1. Find the value of a constants a and b. Okay. First, we have polynomial f of x is equals to 2x to the power of 3 plus ax squared plus bx minus 30. Okay, since x plus 2 is a factor, means that x plus 2 is 2x to the power of 3 plus ax squared plus bx minus 30 is divisible by x plus 2, which means that x plus 2 is a factor. Then if we let the divisor x plus 2 equals to 0 such that x equals to negative 2, since x plus 2 is a factor by factor theorem, f negative 2 should equals to 0. So which means that we have 0 equals to 2 times negative 2 to the power of 3 plus a times negative 2 squared plus b times negative 2 minus 30. Okay, using your calculator, you should get negative 46 plus with 4a minus with 2b is equals to 0, and then we can divide, we can bring negative 46 to the left hand side, so we have 4a minus 2b equals to 46. Simplify, everything can be divided by 2, so 23 equals to 2a minus b. Okay, that is the first equation. Now let's have a look at the second equation. Second fact, we want to find another equation. Since we have a and b, we need to find both constants a and b involving two variables. Means that we need to find two equations so that we can do simultaneous. Okay, for the second equation that we want to find, it is stated that this polynomial here leaves a remainder of negative 35 when divided by 2x minus 1. So we let divisor 2x minus 1 equals to 0. So we have x equals to 1 over 2. Hence, by remainder theorem, r is just equals to f 1 over 2. So the remainder given is when the polynomial is divided by divisor 2x minus 2 to x minus 1, we will get remainder negative 35. So negative 35 is just equals to 2 times 1 over 2 to the power of 3 plus with a times with 1 over 2 squared plus with b times with 1 over 2 minus with 30. Let me use my calculator for a while. So I'll get here is 1 over 4 plus with 1 over 4a plus with 1 over 4b equal, sorry, 1 over 2b equals to, okay, this one I bring to the left hand side, so it becomes plus 13, so we will get negative 5. and multiply everything with 4, we should get negative 20 equals to 1 plus a plus with 4 divided by 2b. So we can have a plus 2b is equals to negative 21 as our second equation. Okay. Now we can compare our first and second equation. You can do simultaneous, you can do substitution. It depends on how you want to do it. Since I have a plus 2b equals to negative 21, hence I let a is just equals to negative 21 minus 2b as equation number 2. So I'm doing substitution, so insert 2 into 1. Okay, so we have 23 equals to, let me see, 2a. A is equals to negative 21 minus 2b. 2a minus b. Okay, so let's try to simplify this. So 23 equals to negative 42, negative positive, negative 4b minus b. Okay, so bring here 23 minus 42 equals to 1. We can simplify, we get negative 5b. So b is just equals to, this is plus, sorry, 23 plus 42, 65 divided by negative 5. So we should get b equals to negative 13. Now we already find the value of b. We can find the value of a. A is just equals to, from here, maybe, negative 21 minus 2 times b, which is negative 13. We should get 5. Ta-da! So b is negative 13 and a is equals to 5. Okay, the last part of this chapter would be solving cubic equations. So let's have a look at example on how to solve cubic equation. Suppose that I have these polynomials equals to 0. So we want to solve this equation. First and foremost, if you have a look at this equation, our main aim is to find the value of x such that when we insert the value of x inside x, we will eventually get a 0 here. So to solve this, the first thing you need to know, you need to see the term without x. Okay, we have negative 12. Okay, negative 12 is just equals to 1 times negative 12, or negative 1 times 12, or 2 times negative 6, or negative 2 times 6, or 3 times negative 4, or negative 3 times 4. I think those are all the possible integer combination. Hence we can have factors of negative 12, we have 1, negative 1, 2, negative 2, 3, negative 3, and 4, negative 4, 6, negative 6, and 12, negative 12. These are all the factors of negative 12. So what I did is I just list down all these factors here. The next step will be you need to find which of these possible factors, when we insert into the polynomial, we will get 0. So by try and error, let's try first f1, which is just equals to 5 times 1 to the power of 3 minus 3 times 1 squared minus 32 times 1 minus 12. You should get, let me try. It's negative 42. So it's not 0. We need to find value of this equals to 0. Okay, the next one, we try f negative 1. So it's just equals to 5 times negative 1 cubed minus 3 times negative 1 squared minus 32 times negative 1 minus 12. We should get minus 3 times negative. Sorry about the delay because I'm currently using the calculator to find the value. Not sure this is correct or not, but I get, should try again, negative 1, 3 minus 3 times 10. Squared so we will get 12. How about we try f2, 5 times 2 to the power of 3 minus 3 times 2 squared minus 32 times 2 minus 12. Negative 48, so this is still not the answer. We try f negative 2. So we will have 5 equals to negative 2 cubed minus 3 times negative 2 squared minus 32 times negative 2 minus 12. And we'll get 0. So this is not the answer, not the answer. We need to choose that. So we need to choose when x equals to negative 2, hence x plus 2 is a factor. Remember, when we bring x minus 2 to the left hand side, we can x plus 2, and x plus 2 is a factor. The next step, we need to do the long division. Okay. After we find our factor, we need to do the long division. So we do the long division. So we have 5x to the power of 3 minus 3x squared minus 32x minus 12 divided all this by x plus 2. Okay, I'll move to the right hand side a bit. Right, so now you do the long division. What times with x? We get 5x cubed. So we need to times with 5x squared. 5x squared times with x, we get 5x cubed. 5x squared times with plus 2, we get plus 10x squared. Okay, top minus bottom. First term, we get 0. Second term, negative 3x squared minus with 10x squared, we will get negative 13x squared. Okay, bring down the next term, minus 32x. What times with x? We get negative 3x squared. We need to times with negative 13x. Negative 13x times x, we get negative 13x squared, negative, positive, negative 26x. Okay, top minus bottom. So here will be cancelled out. Negative 32 minus with negative 26. Negative 32 should get negative 6x. So this becomes negative 6x minus 12. Okay, what times with x? We will get negative 6x. Negative 6 times with x, we will get negative 6x. Negative, positive, negative 6 times 2, get 12. Top minus bottom, the remainder is 0. As we know, since x plus 2 is a factor of 5x cubed minus 3x squared minus 32x minus 12, then the remainder should get 0. Which means that in terms of dividend, quotient, dividend is equals to quotient times divisor plus with remainder. We can rewrite this as fx equals to quotient times with divisor plus with remainder. So fx is 5x to the power of 3 minus 3x squared minus 32x minus 12 is just equals to qx is 5x squared minus 13x minus 6 times with divisor is just x plus 2 plus with remainder is 0. So we don't have to write anything with the remainder. Now, can we factorize this? Yes, we can. Equals to, let me see, 5x x 3, 2, okay, we try this. 3 and 2. You can use factorization. You can use your calculator. It's negative 15 plus with 2x, negative 13. So from when we factorize this, we will get that 5x plus 2 minus 3 times with x minus 3. Next, we just bring x plus 2. So equals to, hence, we let this equals to, obviously, equals to 0 means that this is equals to 0. Hence, all of this is equals to 0. So we have 5x plus 2 equals to 0. X equals to 2 over 5, comma. Done with that. Sorry, negative 2 over 5. And then x minus 3 equals to 0, therefore x equals to 3. And the last one, x plus 2 equals to 0, x equals to negative 2. So that is your answer. Have a look at this question. Solve 3x cubed minus 14x squared plus 32. Okay, look at 32. We need to find the factors of 32. 32 is just equals to 1 times 32, or negative 1 times negative 32, or maybe 2 times 16, or negative 2 times negative 16, or can we divide it with 3? Let's try. Of 4 times with 8, or negative 4 times with negative 8. I think that's it. So factors of 32, we have 1, negative 1, 2, negative 2, 4, negative 4, and then 8, negative 8, negative 16, 16, negative 32, 32. Next step, by trial and error, we should try each one of these factors, so that when we insert into the expression here, we will get 0. So we try one by one. Try f1 equals to 3 times 1 to the power of 3 minus 14 times 1 squared plus 32. You should get 3 minus 14 plus 32. Okay, 21. So this is not the answer. Try f negative 1. So 3 times with negative 1 cube minus 14 times negative 1 squared plus 32. You'll get 15, so this is not the answer. How about if we try f2? This is not f2. So equals to 3 times 2 cube minus 14 times 3 squared plus 32 equals to negative 70. So this is also not the answer. We should try f negative 2. So 3 negative 2 to the power of 3 minus 14 times negative 2 squared plus 32. Negative 48, also not the answer. We try f equals to 4. So 3 times 4 to the power of 3 minus 14 times 4 squared plus 32. Oh, then we will get 0. Now we have found our factor after a long trial and error. So we let x equals to 4, hence x minus 4, bring that to the left as well. X minus 4 is a factor. Okay, we found one factor. Right now, we need to find the other factors. So what you need to do, we need to do the long division. Okay, so we have 3x to the power of 3 minus 14 x squared plus, with there is no term with x, so we just add 0 x, and plus with 32. This is necessary. Adding a term which is not exist by letting, in this case we let 0x, you need to do this in order for you to do long division. Okay, so plus 32 divided by, again, the factor just now, x minus 4. Since x minus 4 is a factor, I would expect that the remainder will equals to 0. So what times with x? We get 3x to the power of 3. We need to times with 3x squared. So 3x cubed, 3x squared times with negative 4, we will get negative 12x squared, top minus bottom. So 14 minus with minus 12, so we will get negative 2x squared, bring down the next term plus 0x. So again, the same process. What times with x? We will get negative 2x squared. So we need 2 times with negative 2x. Negative 2x times with x, we get negative 2x squared. Negative 2x times with 4, negative times negative, positive 8x. So top minus bottom. So we will cancel out the first term. So 0 minus with 8x, we will get negative 8x. Bring down the next term, which is plus 32. Okay, what times with x? We will get negative 8x. Negative 8. Negative 8 times with x, we will get negative 8x. Negative times negative, positive. 8 times 4, 32. So top minus bottom, we will get 0 remainder. Hence, it is true that this divisor, x minus 4, is a factor. The next step, write in terms of, remember just now, dividend is equals to quotient times divisor plus with remainder. So we just write that in a form of, I should use other colors, maybe pink. So we have 3x to the power of 3 minus 14x squared plus 0x, no need to write 0x, plus with 32 is just equals to 3x squared minus 2x minus 8, this is qx, times with divisor x minus 4 plus with remainder. So remainder is 0, so you don't have to write the remainder. And again, this whole thing is equals to 0. So equals to 0. Okay, can we factorize that? Yes, we can factorize that. Becomes 3x, then x. Let me see, what can we do? 4, 2. Okay, try 4 and 2. Negative 6x plus with 4, we get negative 2x. Times with x minus 4 equals to 0. Now we bring down that. Okay, now we have 3x plus 4 equals to 0. Hence, x equals to negative 4 over 3, comma. Second one, x minus 2 equals to 0. Hence, x equals to 2. The last one is x minus 4 equals to 0. X is equals to 4. So final answer, x is just equals to negative 4 over 3, comma 2, comma 4. So end of our chapter. Alright, then that's the end of our chapter, factors of polynomials. So for your school holiday homework, please complete chapter factors of polynomials and also permutation and combinations from in your topical past year workbook. If you have any questions, you may email me or WhatsApp me and we can discuss the question. Make use of your holiday wisely and happy holiday and selamat hari raya. Awal sangat tapi selamat hari raya. Bye bye.